Hi there. Now in this question we're told that a curve is described by the equation x squared plus 4xy plus y squared plus 27 equals 0. And we've got to find dy by dx in terms of x and y for 5 marks. So if you'd like to have a go at this, I'll just give you a moment to pause the video, and when you come back I'll take you slowly through the work solution. Okay, welcome back then if you had a go. Well, the first thing I'd want to do anyway is we'll just write down the equation, and what we've got here is what is often termed an implicit equation. Okay, it's got x's and y's all muddled up here, okay, rather than just y equals some function of x. So we're going to need to use implicit differentiation to be able to differentiate this. And if you're not sure of that, just do take a look at the videos on my website. So what we need to do then is differentiate this with respect to x. And I'd always encourage you to put something like that down when you're doing implicit differentiation. Don't fall into the trap of writing dy dx equals, okay? It's not that kind of question. So differentiating x squared with respect to x is just going to be 2x. But when we come to differentiating this term, 4xy, what we've got here is a product of two functions. A function of x here, and we've got then y. So to do this, we've got to use the product rule for differentiation. So we're going to take one part, the first part, say, times it with the differential of the second part, and then plus the second part times the differential of the first part. So that's the product rule. So let's do that. We've got plus here, and if we take the first part, 4x, I'll put that in brackets, okay, and we multiply it by the differential of y with respect to x. So that's just going to be differential of y with respect to y is going to be 1. I'll put that in, and then we times it by dy by dx. That's implicit differentiation there, okay? We're still with the product rule, so it's plus, and now we take the y and we multiply that y by the differential of 4x with respect to x, which is going to be simply 4. Okay, so we're done with differentiating 4xy here. Now we move on to differentiating y squared. So differentiate that with respect to y, and it will be 2y. And then we have to multiply it by dy by dx. Again, implicit differentiation there. For the 27, that's a constant, so that's going to differentiate to 0. And if you differentiate 0, that's going to be 0. So there we go. We just need to tidy this up to get dy by dx. So we've got the first term, 2x. Next term here is plus 4x dy by dx. And then we've got plus 4y. And then finally here, plus 2y dy by dx. And that equals 0. And what I'm going to do now is we'll bring the dy by dx terms, we'll keep them on the left hand side, and we'll take the 2x and the 4y to the other side. We'll take 2x and 4y then from both sides. I'm also going to, I'm just going to pull out dy by dx on those two terms. So we've got 4x plus 2y, put that in brackets, and that's combined with the dy by dx. Notice how I've written the dy by dx at the rear of the bracket here rather than the front. And then we're taking these two terms from both sides, so we're going to have minus 2x minus 4y. So now we'll just section this off. So if I now divide both sides by 4x plus 2y, we're therefore going to have dy by dx equals, and not only am I going to divide by 4x plus 2y, but I'm going to factorize these two terms here by pulling out minus 2, and so I'd have x plus 2y. And when it comes to dividing by 4x plus 2y, I'm going to pull out a 2 across these two terms here. So that'd be 2 times 2x plus y. And so I can cancel this 2 with that 2 there, and we end up with, therefore, dy by dx equals, and then I've got minus, I'll pull the minus way out the front of that division, and I'm just left with x plus 2y divided by 2x plus y. I could obviously just leave the minus on the top here and just write minus x minus 2y, but I prefer this particular version of the answer. All right.